This video was produced as part of Europe's Rail, Flagship One MOTIONAL project. The video present ongoing work and the status in the project that will end in September 2026.
Flagship One MOTIONAL has received funding from the European Union's Horizon Europe Research and Innovation Program.
The purpose is to develop and demonstrate solutions for future capacity planning and traffic management. Our approach with planning and traffic management is integrated.
Through an advanced integration of planning and operation management, and by our integrated approach, we develop and demonstrate forward-thinking solutions for future capacity planning and traffic management.
For planning and operations, we have created 3 clusters, all with specific content. These are the Integration and Cross-Border Cluster, the Decision Support Cluster, and the Simulation and Operational Feedback Loop Cluster. In total, we plan for 58 demonstrations, sorted out in the 3 clusters, and we present 3 planned demonstrations.
A large group of stakeholders will carry out capacity planning and traffic management developments and demonstrations on European networks, corridors, nodes, and smaller lines. As shown in the map, the active partners and stakeholders comes from Sweden, Norway, the Netherlands, Germany, Austria, France, Spain, Italy, and the Czech Republic.
The first cluster is the Integration and Cross-Border Cluster. In this cluster, we plan for 16 demonstrations in 2026, and one of these is a demonstration of cross-border traffic management systems, supporting cooperative planning applied between Sweden and Norway.
Imagine that you are a traffic controller at the Swedish Transport Administration, TRAFIKVERKET, and plan the train from Gothenburg to Oslo. This train is expected to cross the border between Sweden and Norway around 7:40, and you are interested in checking if there are any expected obstacles. Opening the network view of your traffic management system, you see relevant part of the Swedish rail network, extended by a section behind the border on the Norwegian side. The pink marker on your monitor indicates the border between the 2 countries.
Let's zoom in a bit on the microscopic infrastructure model, which shows track sections and signaling system details down to signal berth level. The zoomed-in view now shows the cross-border handling location Kornsjø.
Imagine if your counterpart, that is the traffic controller on the Norwegian side, had the same traffic management system capability. That would mean that both national traffic management systems would then be able to exchange operational plans and forecasted train information via standard interfaces.
By selecting the IC382 from your train list, the train route is indicated up to the end of the extended line section behind the border. Your counterpart in Norway also selects the IC382, operating inbound on Norwegian territory towards Oslo.
Having a look at the train graph view of your local traffic management system, you can see that IC382 runs into obstacles between Kornsjø and Halden on the Norwegian line section. This is because an accidental possession of the track, which previously has been published by the traffic management system on Norwegian side using a standard interface.
Theoretically, the train could await the end of the possession, that's estimated to 9 o'clock, on a separate track at the station Kornsjø. But unfortunately, the only fitting track at Kornsjø is not available, so you must find other possible measures on your local network.
Since the train is about to depart from Gothenburg, you might decide to hold back the train where it currently is, or stop the train somewhere else, or instruct the driver to run with reduced speed.
Of course, IC383 running in the opposite direction has a similar problem, and your counterpart in Norway has similar options to pre-align his operational plan to solve the upcoming problems. The bottom line is as follows. Having information about what will happen is the first step towards solving the problem.
Therefore, are we working on the next step? A cooperative approach to support neighboring cross-border traffic controllers to align their decision-making to ensure future smooth cross-border operations.
Now we focus on the second cluster, which is the decision support cluster. We plan for 27 demonstrations in 2026, and one of these is a demonstration of decision support, the optimization algorithms for train scheduling from our project partner, Norwegian Railway Directorate.
In Flagship 1, MOTIONAL, we are developing algorithms for automatic conflict detection and resolution to support advanced traffic management tools. These algorithms have the potential to significantly improve punctuality and efficiency while also increasing the capacity of the railway infrastructure. This train playground demo illustrates the capabilities of a state-of-the-art optimization algorithm for train scheduling based on decision intelligence. This time-space diagram can be used to represent train schedules for a line in southern Norway. Using a finger or a mouse, one can literally draw a desired schedule for a train, shown with a dash line. Then, the algorithm computes a feasible schedule for this train that is as close as possible to the desired one, shown as a solid line. Whenever two or more schedules are in conflict, the algorithm automatically computes new feasible schedules for all trains, where all conflicts have been resolved optimally to reduce delays. Within a single railway line, this algorithm can automatically reschedule tens of trains in real time. The expected results of Flagship 1 MOTIONAL also include extensions of these algorithms to cross-border scheduling and yard scheduling, which will be demonstrated to train dispatchers, capacity planners, and train operators. An example is the cross-border scheduling on the Malmö-Alnabru line, which connects freight terminals in Sweden and Norway.
Finally, we complete our clusters with the third cluster, which is the simulation and operational feedback cluster. In this cluster, we are planning for 15 demonstrations in 2026. Our focus are models to simulate large networks, methods to close the gap between planning and operations, and simulations for ERTMS and ETCS, and traffic management systems interacting with automatic train operation or connected driver advisory system. The following demonstration from Sweden is about simulation to secure effective and safe ETCS implementation.
In TRAFIKVERKET's new ETCS implementation strategy, line-side and in-cab signaling coexist during ETCS implementation. The strategy aiming to reduce closed track due to track work in the implementation phase will be examined in a train driver simulator in a simulated part on a high-traffic line, Stockholm-Malmö. Braking behavior and runtime will be studied. Eye-tracking data will be analyzed to investigate traffic safety effects.
Simulation film shows part of simulated test scenario where the train transitions from Swedish line-side signaling system automatic train control to in-cab signaling system ETCS. As you can see, the implementation method contains much outside and in-cab information to be processed. 24 seconds into the film, a rail worker is standing on the left side of the track, aiming to collect data about drivers' attention and actions. Expected results are information about the driver's braking behavior and safety aspects, as well as driving times in order to measure effects on capacity.
Now, a few words about the interaction between Flagship 1 MOTIONAL, System Pillar, and RailNet Europe.
From the beginning, Flagship 1 MOTIONAL, System Pillar, and RailNet Europe have been working closely together to ensure coherent, good results for Europe's rail system. We have an ongoing dialogue about technical and strategic topics.
Whereas the system pillar is responsible for general design principles and standardization, and RailNet Europe provides input from other sector activities, Flagship 1 MOTIONAL is performing the detailed specifications, developments, and demonstrations. The roles for Flagship 1 MOTIONAL, System Pillar, and RailNet Europe are described in the slide.
Through this regular interaction, we have been able to agree on critical issues, as well as to agree that we don't always agree. But to have always an open dialogue about strategic topics and to address critical issues between each other as well as establish joint working arrangements when needed.
The collaboration that we jointly established will become even more important during the rest of the project work, during the demonstration phase, and in future waves, and might be extended to other sector organizations in future.
The system pillar is the generic system integrator of Europe's rail. The transfer of R&D results into the European harmonization and regulation process is crucial, and the STIP provides the public overview of the outputs and their link to harmonization. Collaboration with FP1 MOTIONAL has been key, since they provide important input to harmonization activities and support results through demonstration.
At RNE, we consider digitalization as a major contributor to an efficient railway system. Thanks to the alignment with Europe's rail innovation pillar, we assure that developments in digital solutions are aligned. We do this for both capacity management and traffic management. The aim is the best possible return on investment. A good collaboration is key to evolve towards a better railway system.
The developments done in FP1 for the traffic management area and all of its aspects are key to ensure an improved usage of the existing infrastructure and to achieve the vision of a single European railway area. Today, rail transport is for various reasons managed at national, regional level, but with the increasing share of international trains, which have in some regions also considerable effect on the national traffic, even if their share is less than 10%, it is of high importance to ensure that national planning and management systems are enabled to be fully integrated in a European CMS and TMS approach.